The ice and rain protection systems permit aircraft operation in various environmental situations, including icing conditions. In flight, icing conditions are defined in the aircraft flight manual as follows. Total air temperature at or below 7 degrees Celsius and, in addition, visible moisture. Entering icing conditions is only triggered by pilot detection. That leads to activation of the aircraft anti-icing system. Primary ice accretion detection device is the Ice Evidence Probe. The Ice Evidence Probe is under the left side cockpit window and visible by both flight crew. It enables the flight crew to visually monitor the beginning of ice accretion before ice builds up in other parts of aircraft airframe. An integrated light is provided to help ice accretion monitoring at night, linked to navigation lights. IEP is specifically designed and positioned to be the first airframe area to be covered by ice and the last to be clear of ice. That leads to activation of the aircraft de-icing system. An ice detector is located under the left wing. It detects ice accretion within a dedicated temperature range. As ice accretion detection is not perfect, the ice detector is considered as a secondary ice accretion detection. IEP is the primary ice accretion detection system. That leads to activation of the aircraft de-icing system. Ice and rain protection of the aircraft is ensured by permanent protection, probes heating and windshield heating, anti-icing systems, de-icing systems. Permanent protection is composed of probes heating, captain, standby, first officer and windshields heating, left and right. To prevent icing on air data sensors, electrical heating is provided for. Captain and first officer, pitot tube, left and right static ports, angle of attack probe, TAT probe. Standby, pitot tube, left and right static ports. The probes are heated both on ground and in flight, except TAT sensors heating which are inhibited on ground. Static ports and alerts are supplied by direct current, others permanent heating are supplied in AC world. Left and right windshields are protected against ice by an electrical heating transparent film. Windshield temperature is controlled to keep outer windshield temperature over 2 degrees Celsius. The inner surface remains above 21 degrees Celsius to prevent mist formation. Windshields heating is supplied by AC world. To protect the aircraft from ice accretion, anti-icing systems are fitted on propellers, flight controls, side windows. Anti-icing systems are electrically supplied by AC world. Angle of attack protection thresholds are automatically adapted to icing conditions as soon as flight controls anti-icing are selected on. System reverts to normal conditions threshold after pilot cancellation. De-icing pneumatic systems are designed to remove ice built up from aircraft critical areas. Protected areas are inner, center and outer wing leading edges, horizontal tailplane leading edge, engines air intakes and gas paths. Boots are installed on protected areas. They are inflated and deflated on automatic sequencing to remove ice, depending on SAT. The ATR 72-600 is fitted with 2 wipers, one on each pilot's windshield. Maximum speed to operate the wipers is 160 knots. The Aircraft Performance Monitoring System monitors aircraft in-flight performance, in order to enhance flight crew awareness about any degradation of performance, and especially in icing conditions. The APM function is a part of the multi-purpose computer. The ice protection system's controls are located as follows. The permanent protection controls with probes and windshields heating. The anti-icing controls with propellers 1 and 2, horns and side windows. The de-icing controls with engine 1 and 2, and airframe. The wipers controls with 2 rotary switches for captain and first officer enabling 2 different speeds. The APM controls is located on central panel. The permanent protection is always active when the aircraft is in flight. The system is set on or off on ground according to the checklist. Propeller anti-ice is performed by resistors, installed near the surface of the inboard sections of the blade leading edges. When selected on, the propeller anti-ice system starts to heat the blades only when NP is sensed above 63%. 2 modes are available. In automatic mode, the D anti-icing mode sail auto push button is released, and enables the automatic operating mode. In man mode, the D anti-icing mode sail auto push button is pressed in, and mode sail push button is operative and available, according to SAT. Flight controls anti-ice consists on heating ailerons, elevators, and rudder horns. Side windows are protected by a heated system made up of small wires. It keeps in a temperature above 21 degrees Celsius. When engine de-icing is selected on, the associated air intakes and gas paths are de-iced. When the airframe is selected on, wing and tailplane boots are inflated and deflated in order to de-ice the leading edges. The de-icing circuit is permanently pressurized by high-pressure compressor. When de-icing engine 1 is set on, the engine 1 boots are inflated alternately by the dual distribution valve. The same occurs with engine 2 de-icing switched on. When the airframe is switched on, all de-icing boots are supplied alternately by the associated dual distribution valves. The cycle is automatically managed by the MFC with different cycles depending on SAT. The APM system compares the aircraft theoretical drag with the current drag, and alerts the flight crew if reduction of aircraft performance occurs. If drag and/or speed decay exceed predefined threshold values, the corresponding messages or caution alerts are triggered. The APM can trigger 3 different alerts. In case of the anti-icing mode, sail auto fault, master caution, and single chime are triggered. Local alert displays fault in amber on the affected panel. On alerting window, anti-icing auto in amber is displayed. The automatic management is failed. The system has to be switched to manual mode. Then, according to the SAT, the associated anti-icing and de-icing temperature push buttons will be pressed or not. In case of de-icing mode, sail fault, master caution, and single chime are triggered. Local alert displays fault in amber on the affected panel. On alerting window, anti-icing cell in amber is displayed. The automatic management is failed. The system has to be switched to override to use the standby controller. In case of airframe air bleed fault, master caution, and single chime are triggered. Local alert displays fault in amber on the affected panel. On alerting window, anti-icing frame in amber is displayed. The failure can occur in 2 cases: overheat on engines de-icing, or leak on airframe de-icing.